For this example, we're going to be looking at whether or not the age of a mother during pregnancy influences or impacts the number of incidences of Down syndrome. So we want to determine if the data that is graphed is following a linear pattern, and then whether or not it is, we want to figure out, is there a relation, and if so, is it a positive or negative one? So I'm going to plug all of this data in to Desmos using a table. So you can just click add item and add a table, and then go ahead and enter in all of this data, and it will plot on your graph. Now, when you're done doing your plot, you're probably going to have to make some adjustments to your X and Y axes. So remember, you can click the graph settings icon and you can adjust your X axis and Y axis values so that your data better fits your window here. So I'm going to go ahead and input this data and then come back after that. Okay, so now I have my data here in Desmos, and you can see here are my X values. So those are the age of these are the ages of the mother, and then the Y values are the incidences of Down syndrome. So you can see pretty clearly that these points in green are not following a linear pattern. They seem to curve, but they do seem like there's some sort of relationship. So we can see that as the age of a mother increases, we can see that the number of incidences of Down syndrome seems to be actually increasing rather rapidly. It almost looks like it's following some exponential curve. So it is not linear, but there does appear to be a relation between the age of a mother and the number of incidences of Down syndrome. And it appears to be a positive relationship, right? As the age of the mother increases, so too do the number of incidences of Down syndrome. In this next example, we're going to take a look at the weight of specific candy bars and how it relates to the calories in those candy bars. We're going to plot all that data in Desmos, and we're going to find the equation for our line of best fit. Then what we're going to do is we're going to take a look at our results and see what does the slope mean in terms of the context of the problem. And then we're going to use our line of best fit, the equation that we found, to help us find the number of calories for a candy bar that weighs 62.3 grams. So we don't have one that weighs that much in here, so we can actually use our line of best fit to estimate the number of calories that would be in a candy bar of that weight. That's what the whole point of a line of best fit is. So right now I'm going to input my data into my table, and again we're probably going to have to make some adjustments to our X and Y axes so that we can better see our data. So go ahead and input your data now, and I will do the same, and then we can take a look at what it all means. So now I've input my data. Here are my X values. These are the weights of our candy bar, and then the Y values here are the calories for each specific candy bar. And we can see that it kind of gives us just two clusters of data. So a cluster down here and a cluster down here, and there's a lot missing in the middle. But we can still use this data to write an equation for a line of best fit. So if we put our cursor in this cell here, we can use that same formula that we used before. So it's y sub 1. We're still using y sub 1 because we can see that this element or this set is x sub 1, y sub 1. So it's y sub 1 is about mx sub 1 plus b. And voila, we have our line of best fit. I'm going to change the color here because I want to be able to see it a little better. There, so our line of best fit is this line here in blue. So what does it all mean? So remember, R is our correlation coefficient. It tells us how strong our linear relationship is. So this is a pretty strong positive linear relationship. And then here's our value of m, and here is our y-intercept. So this is our slope. So what does this slope mean in terms of the context of the problem? Well, remember, the slope is our change in y over our change in x. It's the change in the number of calories divided by the change in the weight of our candy bar. So what this means is if we increase the weight of a candy bar by 1 gram, that the number of calories that will increase it by 2.88. So basically it's saying that there are 2.88 calories per gram in each of these candy bars. So we can use this data to actually find the number of calories that would exist if we had a candy bar that weighed 62.3 grams. So 62.3, that's just our X value. So we can actually just graph a vertical line. If we graph a vertical line with the X value that we want, and then look where that vertical line intersects our line of best fit, that will actually give us the Y value, which is the number of calories for the specific given X value. So X equals 62.3. So we have X equals 62.3 there. So here, if we look at this point of intersection, we see that a candy bar that has 62.3, that weighs 62.3 grams, will have 277.24 calories. So roughly 277 calories. So that's how you use a line of best fit to estimate values in your given problems, right? And if we wanted to write the equation for our function, our equation would be f of x equals m. Our m value is I'm going to round to the hundredths, 2.88x plus our value of b, which is 97.59. 97.59. So this would be our equation. So we have two ways that we could approach this. We could just graph this vertical line, or if we wanted to, we could take 62.3 and substitute it in for x and do the calculations this way. So that's what we use a line of best fit for, to estimate values that are unknown and use it based on our given data.